In this question, we have to find the value of this current I bar through this capacitor using superposition principle. Notice that we have two sources, one voltage source, one current source. So to use superposition principle, we have to make two copies of this circuit, okay, like this. Here is one copy and here is another copy, and we shall consider the voltage source and the current source individually, separately. So from this original circuit, we have made two copies, and in this copy, I will keep the voltage source and I will remove the current source, and it will be replaced with the internal impedance of this current source, which is infinite. That means open circuit. And in this copy of the original circuit, I will remove the voltage source with its internal impedance, which is 0 for a voltage source. So I will replace it with short circuit, and this current source will be kept. Okay, so we shall consider the voltage source and the current source separately. Each source is used exactly once. The voltage source is used here, the current source is used here. Now, suppose the value of this current through the capacitor due to the voltage source alone is I superscript 1, and the value of this current here through the capacitor due to the current source is I superscript 2. Then definitely this current I in the original circuit will be sum of I1 plus I2 due to both the voltage and current source together. Okay, so definitely so here finally I will be equal to I1 plus I2. But before that, we have to calculate the values of I1 and I2 from these two circuits. Now, in this circuit, I superscript 1 is the current that flows here, then here, then here, then through the source, and so on. So I1 is same as this source current. And how much is this source current? Okay, so I1, I superscript 1 is same as the source voltage, which is 12 angle 30 degree divided by the total impedance from here to here across the source. How much is the total impedance? Now let me start calculating the total impedance from the bottom. So here we have 10 minus J18, okay, 10 minus J18. So this is the impedance of the capacitor and this resistor together. And after that, from here, we have two parallel paths. One is this one, and the other is this one. Okay, so how much is the equivalent impedance of these two paths in parallel? So that will be 10 plus J2, 10 plus J2 in parallel with 20 plus J5, 20 plus J5. Okay, so this will be same as 12 angle 30 degree whole divided by 10 minus J18 plus 10 plus J2 into 20 plus J5 divided by 10 plus J2 plus 20 plus J5. Now if you simplify this using a calculator, then it will be approximately equal to 0.510 75 and with an angle of 74.8037 degree. This is in ampere. Okay, so this is the value of I1 due to the voltage source alone. Now let us find out how much is this current through the capacitor due to this current source alone. Okay, so for that it will be visually pleasing if I redraw this circuit like this. Okay, let me put this resistor here and this is connected here. Okay, and then as you can see that there is another path, another connection like this. Okay, and this resistance is 10 ohm. Now notice that this one angle 120 degree, this current comes here and then it finds two paths, one through the 20 ohm resistance and another through this inductor. Then that current, after reaching to this junction, again it finds two paths, one through this 10 plus j 2 ohm path, another is through the capacitor, which is what we want to calculate. So therefore we will apply current divider rule twice, once here and then here, to get the value of I2. Okay, so let us calculate. Notice carefully. So at this point, okay, at this point the total current coming in is 1 angle 120 degree. Then there are two paths. How much goes through the inductor? So that will be this total current multiplied by the ratio of this upper impedance 20 divided by the sum of the impedances of the two possible paths. Okay, so that means 20 plus the impedance of the this lower path from here to here, total impedance. Okay, how much is the impedance from here to here considering these two together? So let me indicate that this way. Okay, so how much is the total impedance of this yellow region from its right side to the left side? Okay, so that is this J5 plus this parallel combination, which is 10 plus J2 in parallel with 10 minus J18, 10 minus J18. Okay, so this is therefore this quantity, this entire quantity is the current through this inductor. Now again this current is divided into two parts at this point. One of them goes through the capacitor, and that is what we want to calculate. How much is this current through the capacitor? So that will be this total quantity multiplied by the ratio of this 10 plus J2 divided by 10 plus J2 plus this lower path 10 minus J18, 10 minus J18. Okay, so if you so this is the current I superscript 2. Now if you simplify this, this will be 20 angle 120 degree, then 10 plus J2 in the numerator, and then in the denominator we have 20 plus J5, then plus this parallel combination which is 10 plus J2 into 10 minus J18 whole divided by 10 plus J2 plus 10 minus J18. Okay, then this entire thing is further multiplied by this quantity, so 1 over 20 minus, this is 20 minus J16. Okay, so this is in ampere, this is in ampere. This is the current I2 due to this current source alone, and according to my calculation this is equal to 0.2818 with an angle of 162.98 degree ampere. Okay, now if we add I2 and I1, that will give us the total current I in the original circuit when the voltage source and the current source both are present together. Okay, so finally, therefore, you have to add this value, and the result according to my calculation is 0.5911 with an angle of 103.26 degree, and this is in ampere. Okay, so that is the answer. Please check whether my calculations are correct.